4 planets discovered in orbit around a nearby red dwarf star. Despite being closer to the size of Jupiter than the Sun, Barnard star is at the center of its own little solar system. Sol Hellier says Barnard star is a small dim star of the type that astronomers call red dwarfs. Consequently, even though it's one of the closest stars to Earth, such that its light takes only 6 years to get here, it's too faint to be seen with the naked eye. Now 4 smaller planets have been found orbiting the star. Teams in America and Europe achieved this challenging detection by exploiting precise instruments on the world's largest telescopes. Diminutive Barnard star is closer in size to Jupiter than to the Sun. Only the 3 stars that make up the Alpha Centauri system lie closer to us. The planets newly discovered around Barnard star are much too faint to be seen directly, so how were they found? The answer lies in the effect of their gravity on the star. The mutual gravitational attraction keeps the planets in their orbit, but also tugs on the star, moving it in a rhythmic dance that can be detected by sensitive spectrograph instruments. Spectrograph splits up the star's light into the component wavelengths, and they can be used to measure the star's motion. A significant challenge for detection, however, is the star's own behavior. Stars are fluid with a nuclear furnace at their core driving churning motions that generate a magnetic field, just as the churning of Earth's molten core produces Earth's magnetic field. The surfaces of red dwarf stars are rife with magnetic storms. This activity can mimic the signature of a planet when there is not one there. The task of finding planets by this method starts with building highly sensitive spectrograph instruments, and they are mounted on telescopes large enough to capture sufficient light from the star, and the light is then sent to the spectrograph, which records the data. The astronomers then observe the star over months or years. After carefully calibrating the resulting data and accounting for stellar magnetic activity, one can then scrutinize the data for the tiny signals that reveal orbiting planets. In 2024, a team led by Jonay Gonzalez Hernandez from the Canary Islands Astrophysics Institute reported on 4 years of monitoring of Barnard star with the espresso spectrogram on the European Southern Observatory's Very Large Telescope in Chile. They found 1 definite planet and reported tentative signals that indicated 3 more planets. And now a team led by Ritvik Dasan, University of Chicago, in a paper just published in Astrophysical Journal Letters, have added in 3 years of monitoring for the Maroon X instrument in the Gemini North Telescope, analyzing their data confirming the existence of 3 of the 4 planets. While combining both, the dataset showed that all 4 planets are in fact real. Often in science, when detections push the limits of current capabilities, one needs to ponder the reliability of the findings. There are spurious instrumental effects that teams have accounted for, hence it's reassuring when independent teams using different telescopes and instruments and computer codes arrive at the same conclusion. The planets form a tightly packed closed system, having short orbital periods between 2 and 7 Earth days. The team looked for longer period planets further out in the star's habitable zone, but didn't find any. Nevertheless, the Barnard star planets tell us about planetary formation. They'll have formed a protoplanetary disk of material that swirled around the star when it was young. Particles of dust will have stuck together and gradually built up into rocks that aggregated into planets. Red dwarfs are the most common type of star, and most of them seem to have planets. Whenever we have sufficient observations of such stars, we find planets, so there are likely to be far more planets in our galaxy than there are stars. Most of these planets that have been discovered are close to the star, well inside the habitable zone, where liquid water could survive on the planet's surface, but that's largely because their proximity makes them much easier to find. Being closer in means that their gravitational tug is bigger, and it means that they have shorter orbital periods, so we don't have to monitor the star for as long. and it also increases their likelihood of transiting and thus of being found in transit surveys. The European Space Agency's Plato mission, to be launched in 2026, is designed to find planets further from their stars, and this should produce many more planets in their habitable zones and should begin to tell us whether our own solar system, which has no close-in planets, is unusual. This is from the conversation by Cole Hellier, Professor Astrophysics, Kiel University, on Unexplained Mysteries. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.